This is chapter 10, first video. Now in chapter 10, we deal with two populations. Like in chapter 8 and chapter 9, we looked at one population. In chapter 8, it was one population confidence interval. And in chapter 9 is one population hypothesis testing. That is, by one population, I mean one mu. Okay. Confidence interval for mu or hypothesis testing for mu, the population mean. Now in chapter 10 we deal with two populations and therefore we have two population means. So here we see some notations. This is the first population with the mean mu sub 1. The subscript 1 indicates population 1. And then the standard deviation of population 1 is denoted by sigma sub 1. And similarly we have mu sub 2 for the mean of the population 2, and sigma sub 2 is the standard deviation of population 2. So obviously we will not have the value, or we won't know the values of mu sub 1, mu sub 2 or sigma sub 1 or sigma sub 2, and our task is to estimate the values for mu sub 1 and mu sub 2. Now in the course of estimation we have to take random samples. So one from population 1 and another one from population 2. So here is sample 1 taken from population 1. Okay, this must be a random sample, and independent of this random sample we take another sample from population 2 and we call that sample 2. So the sample statistics are, we take a sample of size n sub 1 and from that we compute the average of the sample, which is x bar sub 1, and we compute standard deviation from that sample, which is s sub 1. We do the same thing for the second population. So we have n sub 2, x bar sub 2 and s sub 2, and these three are from the second population. Now we need to now estimate mu sub 1 and mu sub 2, and we can use x bar sub 1 as a point estimate for mu sub 1 and x bar sub 2 as a point estimate for mu sub 2. We want to now develop a confidence interval for the difference in the means between the two populations. Okay, so that is the parameter of interest for us. So in the first section in chapter 10, we're going to assume that sigma sub 1 and sigma sub 2 are known. So if the population standard deviations are known, the means are the ones that we don't know. Okay, so the parameter of interest is mu sub 1 minus mu sub 2. Assuming that sigma sub 1 and sigma sub 2 are known, then we know that we can estimate the difference in mu sub 1 and mu sub 2 is x bar sub 1 and x bar sub 2. Okay. That is the point estimate from the sample means that we have calculated. So we estimate that that is going to be our estimate for the difference in the population means. Obviously there is going to be a certain amount of statistical error between what we think the difference is between the population means and what the actual population mean difference is going to be, and that's something that we need to calculate or place a limit on the margin of error. And for that we need to understand that the expected value of this difference x bar sub 1 minus x bar sub 2 is the difference in the actual population means, and the standard deviation for that point estimate of x bar sub 1 minus x bar sub 2, and we call that standard error, is given by this formula. Okay, and since we are assuming that sigma sub 1 and sigma sub 2 values are known, then we can calculate what the standard error is going to be, and based on this information then we can develop a confidence interval for the difference in mu sub 1 and mu sub 2, and for that we have to assume that the samples that we have taken n sub 1 and n sub 2 are large. Okay, and by large we can use the thumb rule that the sample sizes are both greater than or equal to 30. If that is so, then we can assume that the difference in the point estimates will follow an approximately normal distribution. Then confidence interval is given by the point estimate x bar sub 1 minus x bar sub 2 plus or minus the z value from the normal distribution table for a given confidence level. For example, if it is 95% or 99% confidence level, using that we'll look up the z value from the table and multiply by the standard error. So this part is the margin of error and this is the point estimate. And from these two then we get the lower limit and the upper limit for the confidence interval. Now similarly, we can do a hypothesis testing, and again we have three possible types for the hypothesis testing for mu sub 1 minus mu sub 2. So here are the two one-tail tests and this is the two-tail test. So it can be set up in one of these three types only. We can set up the test statistic as z calc with this formula and then compute the p-value, and based on the p-value we can make a conclusion. Now of course all of this will work only if sigma sub 1 and sigma sub 2 are known, but that is rarely if ever the case. So if sigma sub 1 and sigma sub 2 are not known, then we have to estimate sigma sub 1 and sigma sub 2 with S sub 1 and S sub 2 and replace sigmas with the sample standard deviations. When we do that, we can no longer use z distribution. So that we will discuss that in the next section. We're not going to do any numerical examples for the case when sigma sub 1 and sigma sub 2 are known, because that is rarely if ever the case, and the reason why we went over this is to lay the foundation upon which the case when sigmas are not known we can develop the confidence interval and the hypothesis tests.